So in last lecture, last video, we have learned about the levels of measurement of data, that means nominal, ordinal, interval, and ratio. So in this video, we are going to learn about two things. One is classification of statistics, and then we will also learn about descriptive statistics. So if we talk about statistics, then we can broadly classify statistics into two parts. One is called descriptive statistics, and second is called inferential statistics. So what do we mean by descriptive statistics? So descriptive statistics are generally used to summarize or describe the characteristic of the data which you have collected and present it into some meaningful way. So you can use some of the descriptive measures like mean, median, standard deviation, coefficient of skewness in order to give a summary that okay, this is a representation of a data which you have collected. Generally, it is used for the small data sets. And one most important thing about the descriptive statistics that you use data gathered on a group to describe or reach conclusion about the same group only. That means you are not making any generalizations out of the data which you have collected. Let me give you an example to give you more clarity. For example, if I collect the data of last 7-8 years of the PhD entrance exam and if I analyze it, and then on the basis of analysis, I make the statement that 40% of the total applicants who used to appear for the PhD entrance exam qualifies the exam at RK University. So here I have collected the data from the database of RK University PhD entrance exam, and I'm also reaching at the conclusion about the applicants who are appearing for the PhD entrance exam of RK University only. I'm not making any generalized statements that oh, across India or across Gujarat, only 40% of the applicants used to qualify the PhD entrance exam. So this is like again example of descriptive statistics. Now let us understand the inferential statistics. In inferential statistics, the goal is to draw the conclusion from the sample and to generalize them to population. That means we are using a sample data to reach conclusion about the population from which the sample was taken, right? So generally it is used for the purpose of hypothesis testing or maybe making some predictions out of the sample data about the population. Let us carry forward the example which we have discussed to give you the clarity. Now, suppose there are more than 50 universities in Gujarat, and I have collected the data from some of the sample representing university, let's say 25 universities, about that how many students used to appear for the PhD entrance exam and how many of them used to qualify. And after making the analysis, then I reach at the conclusion and making the statement that 45% of the total applicants used to qualify the PhD entrance exam in Gujarat. So here I use the sample data which I've collected from the 25 representing universities to make a generalized statement or to reach at the conclusion about all the universities which are there in the Gujarat. That means I'm making some estimation or I'm trying to infer or predict the data from sample and to reach at the conclusion about the statistics. So I'm using the inferential statistics. I hope that you got a basic idea about what do we mean by descriptive statistics and inferential statistics. So now let's learn some of the measures of descriptive statistics in detail or try to understand what are the different measures of descriptive statistics which can be used to represent the data in much more effective way so that a decision maker can able to interpret the data and make some useful decisions, right? So when we talk about descriptive measures, then we can classify the descriptive measures into four broad categories. That is measures of central tendency, measures of variability, measures of shape, and measures of association. So measures of central tendency just gives us an idea about the central part of the data. Sometimes it also used to call as a measures of position. So the most common measures of central tendency is like mode, which is a highest repetitive frequency, median, which is the middle part of the data, mean, which used to calculate, like take into consideration all the data set and find out the average of the data. Then there are some measures of positions like percentile, decile, quartile. For example, if in a competitive exam, if I want to know what was the score of an applicant who secured 92 percentile, so that I can find with the help of measure of central tendency, which is percentile. Same way, suppose if I want to find that what is the value at first 25 percentage of the data, so that I can find out with the help of quartile. So that is some of the like glimpse of measures of central tendency. Sometimes by only calculating the mean or median, we may not be able to make a decision, or we may not be able to reach at the conclusion about that particular data set. So to enhance our decision making, sometimes we need measures of variability, which talks about the spread of the data or dispersion of the data or fluctuation of the data. So the common measures of variability are range, interquartile range, variance, and standard. And we often see the standard deviation is the most commonly used measures of variability. So along with the measures of central tendency, if we have also calculated measures of variability, you can able to make a better decision, or a decision maker can able to reach at a conclusion, right? Third is the measures of shape. When we are dealing with a large kind of a data, we try to plot that what kind of a distribution it follows, so that we can able to find with the help of measures of shape. So there are three very popular or widely used measures of shape, which is skewness, kurtosis, and box and whisker plot. And last is method of association, which gives us an idea that whether two variables are related with each other or not. And if they are related, then what is the degree of association, whether they are positively related, they are inversely related, or there is no correlation at all. So there are many measures, but most widely used method is coefficient of correlation. So let us try to understand that how, along with measures of central tendency, measures of variability can help us in enhancing our decision by taking one or discussing one example. Before that, let me also give you a glimpse about, like, we have learned about level of measurement and what kind of descriptive statistics we can use for that level of measurement. For example, for nominal kind of a data, you can use mode, counts, and frequencies. For ordinal data, we can use median, minimum value, maximum value, and range. We cannot apply or calculate mean or standard deviation on nominal or ordinal kind of data. We can only able to apply mode and median, or at the max, we can find out the minimum or maximum value and the range of that particular data set. For interval kind of data, you can calculate mean, variance, and standard deviation, whereas ratio, which is the highest level of measurement, you can able to do all these calculations which has been mentioned above. Now let us again discuss that how measures of variability can help you in enhancing your decision by discussing one example. So now in this example, I am planning to invest 1 million rupees. So I got have two options which is available with me: financial security A and financial security B. But when I have collected the data of last 10 years return, and when I calculated the average, which is mean mu, so I found out that on an average, both securities is giving me the same return, that is 15%. So now it leads me to the confusion that which is the better option to invest. So I have also calculated the measures of variability, that means standard deviation, and I found out that for financial security A, the standard deviation is 3%, whereas for financial security B, the standard deviation is 7%. That means that security A is less volatile in nature, more consistent, and able to give me the same return which security B is giving, whereas security B is more fluctuating or more volatile in nature. So from this, like, I can able to enhance my decision making, and I will decide that I should go with security A. But friends, sometimes even we can also came across a situation where the mean and standard deviation for both the data sets are different. That means whenever you are collecting a data from two different populations, where the mean value is also different and standard deviation is also different. So in that case, again, we get confused at which is the better option, or in which data set there is a less variability or less variation. So when you are dealing with such kind of a data, coefficient of variation can be very useful to make a decision making, right? So what is coefficient of variation? It is nothing but a ratio of standard deviation to mean, which is expressed in percentage. So by formula, we can write that like this: coefficient of variation, which is symbolized as CV, is nothing but sigma upon mu into 100. So here I have a two data set A and data set B, which has been collected from two different population. So we can see that for the data set A, the mean is 29. For data set B, the mean is 84. Whereas the standard deviation for the data set A is 4.6 and the standard deviation for data set B is 10. Right? So in the first glimpse, we may say that this might be the less volatile data because the value of the standard deviation is less as compared to data set B. But when we calculate the coefficient of variation, we can find that in data set A, there is a 15.86 percentage of variation, whereas in data set B, there is only 11.90 percentage of the variation. So data set B is less volatile as compared to data set A. So this is a usage that where we can use coefficient of variation when we are dealing with data which came in from two different population and the value of mean and standard deviation is too much vary in nature. Now let us also have a glimpse of how we can use measures of shape. So this is an example or representation of measures of shape, skewness and box and whisker plot. So this three charts you can able to plot from any of the statistical software, which is measures like again which represents measures of skewness, and this the chart which you can see in the box shape is called box and whisker plot. So coefficient of skewness is generally denoted by S, right? So whenever there is a negatively skewed data, the value of coefficient of skewness S is less than 0. This data is a perfect data, or we can say normally distributed data. That means there is equal number of data values on the right side and left side from the mean value, right? And same thing we can see in the box and whisker plot, that equal number of data sets are there on the both side of the mean value, right? But whenever there is a presence of skewness, the data will be either little tilted towards the left side or little tilted towards the right side. So whenever the large number of values or more number of values are on the left side of the mean value, I'm repeating, whenever the more number of values are on the left side of the mean value, we can say that data is negatively skewed, or more number of data are having the higher value as compared to mean value, then we can say that data is negative. Whereas in this example, we can see that coefficient of skewness, the value is greater than 0, and more number of data values are having a value which is less than the mean value, which is less than the mean value. So this will be called positively skewed data. I hope that from this representation of the different kind of distributions or the chart of distributions, you can able to identify whether the data is skewed or not. And same thing you can able to see in the box and whisker plot. So this is a negatively skewed data. This is a no skewed or symmetric data, and this is a positively skewed data. Another measure of shape, which is called kurtosis, which talked about the thickness of the data. So this is a representation of measure of shape kurtosis. So there are three broad classification of kurtosis. One is called mesocortic, which is generally normal in shape, right? So we can see here that if we divide this particular data set from the mean value, we have equal number of data set on the left and right side of the mean value. And generally Ck is the coefficient of kurtosis. So whenever we are dealing with the normally distributed data or mesocortic data, the value is approximately equals to 3. Another classification is leptokurtic data, where the peak of the data is thin, right? And the spread between the lowest value and highest value is very narrow. So this is a less spread data. And generally, if we talk about coefficient of kurtosis, then in this case, the value is greater than 3. Whenever the data peak of the data is too much flat in nature, or the spread between the two data values, or that means lowest value and the highest value is too high, then we can say that the data set is platyphotic in nature. That means spread or dispersion is too high or too widely spread data, right? In such cases, the coefficient of kurtosis, value of coefficient of kurtosis is less than 3. I hope that you are clear about measures of shape. Now let us also discuss about measures of association. So measures of association generally is gives you an idea about the strength and the direction of relationship between the two variables. There are many or several ways to describe measures of association depending on the type of analysis. But most widely used measures of association is coefficient of correlation, which is generally denoted by R. So the range of R is -1 to 1. So whenever there is no correlation between the two data sets, it is represented the value of R can be 0. And you can also, whenever you plot the graph, you will find that the graph will be somewhere like this. Whenever there is an inverse relationship, that means when one variable is increasing and another variable is decreasing, you will find that the value of R is less than 0. And the graph which you plot, this is called scatter plot graph. It will be represented like this, which indicates a negative trend. And whenever there is a positive correlation between the two variables, that means when one value is increases, there is always an increasing another value. We can see that the value of R is greater than 0, and the graph which you plot generally presents a positive trend. So if you use either Excel or SPSS or any other statistical software, it generally gives you this kind of an output. So this is an example of two variables like interest rate and future index. As we can see that whenever there is an increase in interest rate, right, there is also increase in future index. And overall trend seems to be positive in nature. And same thing you can find in the output which generated by the software. As here you can see that there are two variables, interest and future index, and correlation is positive. That means 0.8152. That means 81.52 percentage correlation between the two variables, which is interest and future index. So now I hope that you are clear about measure of association. Let me further describe you like about by taking one example various measures of descriptive statistics. So this is an example of sales data of a company. There are 5 products, product A, B, C, D, and E, and we have a sales data of each month. That means January to December of a particular year. So from this data, we may not able to identify that what is the average sales of each of the product, which product are having the less variability in among each month, what is the range, that means lowest and highest value, right, of each of the product, and whether the more number of values are on the right side of the mean or left side of the mean. So we can take an help of the like again statistical software on Excel or SPSS to calculate various descriptive values. So in the next slide, this is an output which has been generated by Excel. So now we can easily able to make some decisions. Like again, we can see that from the mean value, the highest mean value is of product A, which is 8198.42 thousands of rupees, whereas the lowest average sales is of product C, which is 2768.083 thousands of rupees. Again, if you want to check that in which of the product there is a higher volatility in the each month, then we can also look at the standard deviation. The highest volatility we can find in product E, almost a volatility of 1,362.5089 thousand rupees, right? Whereas the lowest volatility is in product C, which is 372.96 thousand rupees. So standard deviation can give you a glimpse that where there is a more fluctuation, this might be product E might be a seasonal product where there is a more volatility in the sales. If we look at the curtosis, the most of the value is less than 3. That means the data is flat. So that we can easily identify from the range. The range of each of the data set is too high. That means difference between the lowest and highest value. So the spread of the data is too high, and we can able to find that the curve, if we able to plot, then that will be flat in nature. From the curtosis, we can see that most of the product, that means product A, B, C, and D, the coefficient of skewness is negatively skewed. That means more number of values, right, or more number of data set will be on the left side or are having the higher value as compared to the average value. We can see that here the average is 8198, and almost 1, 2, 3, 4, 5, 6, seven values which is greater than the mean value. That's why like the coefficient of skewness is negative in nature. So more number of data values will be on the left side of the mean value, or we can say it is a negatively skewed data. Only one data set which is product D, it is positively skewed. That means more number of values will be less than the mean value. So this is an example of descriptive statistics. I hope that it has been clear to all of you. Another way to represent the descriptive statistic is through graph or charts, which is readily available on both Excel as well as other statistical softwares like SPSS, SAS, and others. So the same data you can represent in a very good way through a visual representation. So these are different kind of charts which I have prepared from that data set. So this always gives us a idea about which data is less fluctuating or which data is more fluctuating. This is a variability of all the products. This is annual sales of all the products. Here we can easily see that the highest annual sales is of product A, then followed by product E, and the lowest is of product C. This is a comparison of last 2 months to see the consistency. Again, this is a month-wise fluctuations. So we can also able to represent the data in a descriptive measures through a visual representation. So from this, I hope that it gives you a very fair idea about various kind of measures of descriptive statistics and classification of statistics. If you have any query, please drop me an email on my email ID chintan.rajan@rkim.ac.in. Thank you. And in next lecture, we are going to learn about